Hello friends, welcome to session 9, comprehensive review of curriculum done so far. Of course, there's a new introduction to the new topic called Podman. So learning objective of this session is to demonstrate how to containerize a software application, test it with Podman, deploy it on Red Hat OpenShift cluster. That's the objective. Going to be hands-on. I'm running on CentOS 8. I have a CRC code ready containers installed on my CentOS 8 machine and it's running successfully, and I'll demonstrate the topics to be covered in this session. So a new container management system. We learned Docker in first 5 lectures, and this lecture is another container management system. Ultimately, whether it is Docker or Podman, we want to manage the containers. We need to create images, build images, deploy them and run them. So to understand OpenShift thoroughly, we need to learn how to build images with Podman. So Podman have emerged to aid the container image building process. It is a constituent of open repository for container tools and stem from Red Hat's mission to excise the Docker daemon from container workflow. Yes, you don't need a Docker daemon. Interesting point to observe is that Docker require a process, daemon process always running, whereas Podman does not have any such process. Podman emulates the various client commands that Docker provides. Amongst the suite of Docker-like command is the Podman command itself, Podman build command, Podman info, Podman status, all the commands. So you just have to replace the word Docker with Podman and you are good to go. Podman, it is used for building container images using Dockerfile as it's a source for the various build steps. In that sense, it is virtually identical to the Docker build command, but without the overhead of Docker daemon. That's the main difference between Docker and Podman. Podman does not run as a daemon process. So it is a daemonless build. Podman attempts to reproduce the entirety of the familiar Docker CLI without the need to run a daemon to serve and act on API requests. Instead of client-server model, Podman implements a local fork exec model, which in Red Hat's eye greatly simplifies the control and security of container lifecycle. Installing Podman. So let's verify, and if it is already installed, we'll see some few commands about the Podman installation. After 2-3 slides, I will demonstrate this process. So yum-y install Podman. If it is not installed, Podman-v will give you the version. Podman info will give you the info of the containers. Now to create a container in pod using Podman, you can run Podman run, but don't map a port. This does more sense when you have more than one container to work with. So let's create a database container and then a WordPress container using that. So let's start the demonstration. So let's install Podman. Yum install Podman. So if it is already installed, it will show the message because I have done that installation in the past. So just to confirm, just to give you the command. Of course, I missed that sudo command because I am running a non-privileged user. So let me add sudo to it. Okay, so you can see that it is already installed. So let's verify Podman -v. So it is 2.0.5. Podman info will give the information about the Podman. So you see what all containers are running. You can see that. So this is the Podman command, Podman info. So host, CPUs, distribution, container, host name, grouping, and it shows the complete details about the Podmans. Even the container store number containers paused running right now, nothing is there. So that's the Podman. So Podman status will also give you the status status. Okay, Podman info is the command, not Podman status. Sorry. Let's create a Podman pod create -name tsp pod and port number 8080 mapped to port number 80. This will create the pod. This is how we can create a pod, and this is simple way, very simple way. Podman pod create name of the pod and port number to specify that. So Podman pod create, we created this pod. This command will create a pod with port number 8080 mapped to inside port number 80. If you then spin up a container listening on port number 80, you will have the connectivity. So to display the list of pods, you can use podman pod ls, that I'll show. So podman pod ls command after this next command. Now create another container. This is the container, the database container to launch MySQL database, because to install WordPress we need MySQL database as well. So podman run as a daemon, restart always, podman pod tsp pod, the pod which we created. MySQL root password is rootdb password, MySQL database is wp, MySQL user is WordPress, MySQL password is for WordPress password, and the name is wp tspdb and mariadb. So let's verify and let's create this another container inside the pod. So to display the list of pods, you can use podman pod ls, and this will show the pod which we created 2 minutes back, and the existing command podman run daemonize, that is detached mode. Just like Docker we had -d option, and the pod is tsp pod, the one which we created. MySQL password, rootdb password, and the database which we want to create. So this will create another pod. It will pull the database from MariaDB. Repo not found. Let's try. This will pull from anywhere. Ultimately, we'll try. Yeah. So ultimately, it has to first it went to registry.access.redhat.com. Then it tried registry redhat.io, and then finally it was able to fetch the image from the Docker Hub. So this says port number 8080 is already in use, starting some containers internal pod error. So we can see that and we can verify that, but yes, we will try once again. So tspdb is already used by another, and you have to remove that container to be able to reuse them. So let's use podman pod ls. Yes, and there are two containers inside this. This is a WordPress container. Podman run restart always tsp pod, and this is WordPress database name. User is WordPress database password, and the WordPress database host and the website. The pod container name is wp-tsp web WordPress. Let's create this WordPress container as well. Notice that I pointed the WordPress DB host in the environment to localhost here. I'm referring to this. That's because WordPress container is going to find the database container on the local host. So let's run that WordPress another container. This will also pull the WordPress. First it is trying on redhat.access.redhat.com, registry.access.redhat.com. Wherever it will find WordPress, it will pull that, and finally it is getting from Docker Hub only. Yeah, port number is already used. I'm removing pods and I'm removing these images. Yes, now I'll create again. So let's create the pod again. So I don't specify the pod. Let me specify the pod, this port number to 8088. And now I create the database container again. So this is MariaDB. Let me create again inside the pod. I just changed the port from 8080 to 88. Now it is done. So let's create the WordPress pod also. This is WordPress. This time it is faster because the images was already downloaded and it has just had to create the container on that image. Now you try Podman pod ls, you'll see the pod is running, and Podman ps will show you the containers running. Podman ps will show you all the containers running, and it is exposed, and the port number 8080 port, and this is mapped to that port. Now let's continue. So I have created these pods. I've created a WordPress container, database container inside the pod I created, and I verified that list using Podman pod ls. I'll show the pod running, and Podman ps that show me the containers which Podman ps command gave me, and that we have verified that. Okay, one was Apache server running and with 8088 in my case, and the another was database. Both containers were running. Now if I open my browser and visit port number 8088, I should be able to see that. Let's verify. So you can see two containers running, and now I'll open my browser to verify these. :8088. And good news that yes, I'm running with the container and my WordPress installation started. Let's install the WordPress. So what we have learned installing Podman so far, creating a pod using Podman, and then deploying containers inside the pod. We created one Podman TSP pod, and our website is fantastically done, and we are good to see the website. Login, and we are logged in. So this is WordPress installed in the local container running inside the pod, and there are two containers running. If you noticed, one was the database container and one was the WordPress container. So two separate containers, and the website is running inside the container. So this is what we have done successfully. So we created one Podman, we created one pod. Inside that pod we created two containers, and inside the containers, one was the database container, one was the WordPress container, and these two containers are successfully interacting with each other inside the pod, and we have WordPress installed successfully. And that's the objective of the session: running containers, running WordPress inside the container. Alright, let me show you the command again. The history of commands to show you, verify what all commands I used. First I installed with errors and everything. I'll show you the starting from first. So I installed Podman with yum install pod. I verified the version, I verified the information about the Podman, and then I created this pod, Podman pod create name tsp pod -p 8080, because this address was being used by some existing program. So it gave me conflict when I try to create a container inside this pod. So that's a Podman detached mode, restart always. Pod is tsp pod, which I created here, TSP pod, and this is the for installing MariaDB inside a container in this pod. And then I created WordPress. To be no interesting point to note that this MariaDB and WordPress, first is search on Red Hat repository, it was not found. Then it searched on Docker repository, it was able to fetch the images from that. So since 8080 port was used, so I was getting the issue that it was being used, and therefore my containers were not running because the port was already in use. So then what I did was I removed the podman pod remove, and then I removed the images also, and then I created the same pod again, but this time changing the port to 8088 and mapping it to port 8088 mapped to internal port of the container to 80. And then I create the same containers again with the same container, TSP pod, MySQL root password, MySQL database, WordPress database, username WordPress, and password for WordPress is this, and TSP DB is the name of the container, MariaDB. So MariaDB was pulled and installed. Similarly, this is for WordPress, this is for Apache Web Server, TSP Web, WP TSP Web, and WordPress installation. And then I verified using Podman PodLS and Podman PS, and then I visit the website on port number 8088, and I installed WordPress on my container. So I'm running two containers inside this pod, TSP pod, TSP underscore TSP hyphen pod, and I successfully installed WordPress, and my WordPress website is running. So we verified the installation of WordPress, we completed the installation of WordPress, and we got the WordPress website up and running. What you can do, best thing about Podman is you can generate a Kubernetes YAML file from the existing pod. That's the best thing. So we can make a YAML file that define all these actions what we have done from the commands. Podman generate kube TSP pod, the pod which we created, output redirection TSP pod.yml, and then we can verify the command. Let's do that. So now I use the command podman generate kube TSP pod, output redirection TSP pod.yml. This will create the Kubernetes specific YAML file which we can deploy in OpenShift. So cat tsp pod.yml, and this is a complete description of what images, what all containers, what all ports, everything what we use. Complete file is created out of this, and this file we can use to deploy application, deploy the same container in OpenShift. Let's try this. So I'm going to my OpenShift. Okay, I'm getting issue. Let me verify this. So this is my deployment. I'm going to create developer add and sample from YAML file. We use YAML file to deploy, and we'll deploy that. So let me verify the YAML file, and let me copy paste the entire content from this YAML file. So this is the YAML file starting from here. Right click, copy, and let me paste it here. Yes, and the podman and creating the container now. Yes, this will create both the container TSP web and TSP DB, and once the podman these pods are created, you will see that. So this is my OpenShift CRC latest version running, and I can show you the monitoring part also, which was not there. So because now I have enabled monitoring on this pod. Now I can go to this, and I'll see my deployments here. This is my TSP pod, the pod which I just created, inside which two containers are running. So I have deployed the same application in OpenShift, where this pod contains two containers. It is working right now. As you see, it will take time because it has to download the has to deploy those images in this. So it is creating. Let's verify. Let's wait for some time. I also worked on some more deployments yesterday on Jenkins and Nginx, and these were independent container, but this time these two containers are being created in this TSP pod. This error comes because of the memory, because of the usage, so I have seen that many times, so it's not a problem. So we'll come back to this. So we have deployed this file, we have seen the content of the file tspod.yml. Podman PS will show you the running images. Stop and remove the pods created if you want to remove that, and you can use the Podman PS. It will show you the image, and then you can stop the Podman stop the containers, and then remove the containers, and then verify. Let's verify that. Okay, so Podman PS, that will show me my containers, the two containers. So I need to first stop the container. This will stop my container, the first container, and then I stop my second container. This is my second container, and let me remove the container now. Podman RM. So this will remove my containers, and then the second one also. This way I removed my container. If I use the Podman PS now, you will see one container still there. So let me remove this also. This already stopped, I believe. If not, I will remove it. Okay, we need to remove the pod. Podman pod ls, this will show me the pod, and I remove this pod rm, Podman pod rm. This will remove my pod. So now Podman pod ls will not show anything. Podman ps will not show anything. So we have done the cleanup process. So no pods running. So we have cleaned up both the containers, because so many pods are running, so many deployments are running. So I'm just cleaning up. And now I'll build another one from YAML file. And now I try the same thing. Create. Now I'll verify again. Using this will be creating now. And this one, Nginx build, let me remove this also. So many pods are running. Because when you are doing testing, now it is running fantastic. Oh no, it is getting error. Alright. Crash, loop back off. Fine. So troubleshooting part will take time. I'll troubleshoot it, and in next session I'll show the same thing, how it works. So we have done the cleanup process. Podman pod ls we have done. Podman remove, Podman stop, we have done that, and we have created the pod with YAML also. Podman play. So this will bring up the pod from the YAML file. That also can be done. The YAML file which we created, it will create the same pod with YAML file, and let's do that from the command line. So we have this tsp pod.yml, and let's play this to create the same set of pods from this YAML, and this will do the exactly same steps. So once you do the deployment manually, you can generate a YAML file, and then you can play that YAML file. It will do the exactly same process, and fantastic. Now it is so fast. You see the comparison, it was so fast. Oh wow, that automatically healed. That pod is running, it's coming back and going. trying. So let's give it time. In the meanwhile, localhost :8088, and my WordPress should be up. Let me verify, it will come back. Okay, so we have played the tspod.yml file to create the pod again and the container inside that pod again. So you visit the URL and it will show the same page again. You can deploy an application in OpenShift using CLI or web console. How can we deploy applications in OpenShift? That we have done in a previous session also. That's because it is a review, so we are doing it again. Once you have deployed the application, you will make it public so that user can access it. You will then reconfigure the running application using environment variables and scale up the number of instances of the application in order to handle the growing amount of traffic. Deploying your first image. OpenShift support deployment of container images hosted on any image registry that can be accessed from OpenShift cluster. The image we will deploy is OpenShift katacoda/blog Django py. The application in the image implement a single blog site that we have done in the process, so I'm not going to demonstrate it. The full name of the image is this. When you leave off the host name for the image registry, OpenShift will default to first looking for the image on any global image registry that a cluster admin has specified in the cluster configuration. And this is precisely implementing it, deploying it from the console. So go to the console, log into the system, and then after logging in, if you want to do it from the command line, you can do it like this. Create a project, OC new project, project name, and to deploy the container image using the OC command, you can do that. That's precisely I would prefer. I would like to show you these two commands, like how to create the project from the command line. In the previous session, I demonstrated deploying the application from the web console. This time I'll show you the same thing from the command line, that is CLI. Let's do this. First we will create the project, OC new project, and we'll keep the same name, and then new app OpenShift katacoda blog Django, and name is blog. So we are going to do this. So here I'm working on this OC command. So first let's create a project, new project. Now you are working in the project. Now let's deploy the sample application on this. So OC new app OpenShift katacoda blog Django, and name is going to be blog. So this is how you can create a project from the command line, and then you can deploy the pod from the command line using OC new app command. And this way we have deployed the app successfully. To see the status, we can use OC status. That will show us the status of the deployed image. So it is running. Deployment number 2 running on 3 seconds, deployed in 8 seconds ago. You can identify to see the details. OC suggest. So these are the commands which are shown directly, and to describe all, you can see OC get all. And this is what we have deployed just now. Now same thing we can verify on the console also. Let's verify. The project name is this time it is different. I created a project user 15, and under this I deployed this project, blog, and I can see that. So we deploy container in OpenShift using CLI. Deploy container in, so first we need to create a project for deploying the container. OC new project, project name, and then we deployed this. When you created the deployment, a series of resource objects will be created that will tell OpenShift what it need to do. In this case, image stream, deployment config, service are created. The image stream is a record of the image you want deployed. The deployment config captures the details of how the deployment should be done, and the service maintains a mapping of instances of your application so that it can be accessed. And OC status will give you this. If you notice, I verify the same thing. OC status in the project default to this, and the blog deploy is this latest and running 2 minutes. We got these details. When a container image is deployed from the command line, the running container will not be visible outside the OpenShift cluster. In the case of web application, you can make it visible by exposing the service with expose command, oc expose service block, and this will create a default root. This will create a resource object called root. Let's do that. So oc expose service block, and it is exposed. Now if I see oc status, I'll see that blogs are created, and now I should be able to see the same here also. And you see the URL is visible now, and I can access the blog. So the default root is created. If we use oc get pods, that will show us pods running inside the OpenShift also. OC get pods, and that will show me my pods running. With the application deployed and visible, you can check the status of overall project using oc status command that we have seen. View details with oc describe resource /name, or list everything with oc get all, and that's the application which we were running. To get a list of the instances of application that were deployed, you can use the command oc get pods. Oc get pods will show you the pods running. We have seen this command also. To get a list of resources objects created for the application, you can use oc get all command, and we will try this command because that will show me everything. Oc get all -o name selector app blog, that will show me everything about this. So oc get all -o name selector app is equal to blog. This will give me everything about my blog. So you see, service, deployment, image stream, and root, everything is created. Configuration for an application can be supplied by using environment variable when running the oc new app command. Oc new app, and this is the same command, but if you want to supply the environment variable, you can use -env, and the blog banner color is equal to green, for example. Later also, by using oc set environment deployment blog banner color is equal to green. So this is what we can set right now, because our it's already deployed, application is already deployed, and the blog is updated. So we can set the environment variable like this. When the environment variables are updated using oc set environment, the application will be redeployed automatically with the new configuration. If you want to see what environment variable will be set in the container, you can see oc set env with -- list option. What all variables can be set, like oc set environment deployment blog -- list, and it will show me what environment variables I have configured for this. Deleting the application, you can delete the app using oc delete command. Like oc, you need to be selective about which resource object you delete to ensure that you delete only those for that particular application. This can be achieved by using label selector that was applied by oc new app and oc expose to the resource object created, like this: oc delete all selector app is equal to blog. So this label selector can be used to delete all the resources for the blog which you created. The pod and replication controller may not be listed in the output from running oc delete, but they will be deleted eventually. This is because they are deleted as a side effect of deleting the deployment config for the application. So let's delete. So we are deleting this, oc delete all. Everything deleted. Importing an image, When you deploy an application from an existing container image hosted on an external image registry, a copy of the image is downloaded and stored into image registry internal to OpenShift. The image is then copied from there to each node in a cluster where the application is run. To track the image that have been downloaded, an image stream definition is created. To see the list of image stream definitions, you can use OC-get image stream, that is IS. Let's try this command as well. OC-get image stream. So right now nothing, because we already deleted. Had we not deleted that, we would have seen that image stream also. Importing image. Because the image is being used as a part of application deployment, it is labeled with the app label for the application. If you delete the application using the label, this will also delete the image stream. That's precisely I was saying that, because we already deleted the application using selector, so image stream was also deleted. If you need to deploy multiple separate applications from one image, you should import the image into OpenShift first using OC import image. Let's import this image in the OpenShift. OC import image and the same image, and I can use confirm -- confirm. So this will import the image into OpenShift. The image is imported. Now we'll see that if you use OC get image stream, and you'll see the image now. You can then deploy the application from the imported image. OC new app, and you specify the image name. Name is blog. In the web console, instead of the image name option on the deploy image page, you will use image stream tag option. Because the image is imported prior to deploying an application, it is not tagged with app label for a specific deployment. So when you delete any application using the label, you will not delete the image stream, leaving it in place for the other applications that depend on it. That's the best part of it. So what we learn: if you deploy application using label selector and you delete it, everything will be deleted. You imported image separately, it is not labeled, therefore if you delete the application which will depend on it, that will not delete the image. So we can deploy the new application based on this image, and then if you delete the blog, it will not delete the image will be left there. And for any application, because there might be multiple applications depending on this image, so they will still be using it. That's all for this session. I hope you enjoyed it. Thank you very much for watching. Bye bye.